So you need to know and understand the unit circle well enough that if I just asked you what is the cotangent of 4 pi over 3, you would be able to answer that. Maybe not, maybe you'd have to think about it for a little bit, but you would be able to answer it. So that's what we want to get to. Knowing the unit circle that well will make you more successful in your math and engineering courses in college. They will enable you to more easily discern patterns and solutions to problems. And for me to encourage you to do that, normally what I do in face-to-face classes is we have a no calculator quiz where I will just ask you questions like, what is the cosecant of 11 pi over 6? And you have to answer that without a calculator. In our at-home environment, we can't do that. But here's the thing. I will meet you one day. I will meet you face-to-face one day. And in this year, I believe it. I believe it will happen. And when it does, I'm going to give you a quiz, a no calculator quiz on the unit circle. So I want you to be ready for that. And so I'm going to also give you a lot of nifty patterns that are going to help you understand this better. Okay, so once I know all the angles, I need to know the cosine, sine, and tangent, and the secant, cosecant, cotangent. All right? So it's all about the coordinates. If I know the coordinates of the point, I know that the cosine of the angle is x, the sine of the angle is the y coordinate, and the tangent, by the way, one that we don't talk about very much, is the slope of the segment back to the origin. I'm going to do a whole separate thing on that, on getting the tangent. So we'll just start with sine and cosine. So first of all, some of these coordinates are pretty easy to get. We can just get them right off the graph. This is the point 1, 0. That's why it's easy to know that the cosine of 0 is 1. All right, this is the point 0, 1. That's why it's easy to know that the cosine of pi over 2 is 0, and that the cosecant of pi over 2 is 1. All right, this is pi, so the coordinates are -1, 0, and this down here is 0, -1. So all those quadrant angles are easy to get. You got the coordinates, you got the sine, cosine, tangent, and everything else. All right. So the hard ones are these ones in the middle. They're hard because they involve, like square roots of 2 and things. All right. So I'm going to show you, though, a nifty trick that can get you all these coordinates in the first quadrant. And then once you have the first quadrant, you can always get the rest of the quadrants by just using reflection. So I'll show you how that works. All right, so first of all, here's the thing. All of these coordinates are the square root of something over 2. All of them are the square root of something over 2. This one is the square root of something over 2. You may have noticed this already. This one's the square root of 2 over 2. So square root of something over 2. I gave it away. This one's square root of something over 2. And this one's square root of something over 2. They're all square root of something over 2. Even this one down here is square root of something over 2. Both coordinates are square root of something over 2. All right? But I told you this was 0, 1. How can that be? Well, I will show you. Okay, so the next thing you need to realize is that as you go up, as theta increases and we go up the unit circle this way, the y's are increasing as we go up. The y's are increasing. All right, so you ready? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. All right, that gives you all of them. Gives you all of them, right? Square root of 4 over 2 is the same as 2 over 2, so that's 1. Square root of 0 is 0. 0 over 2 is 0, so that's 0. All right. Now, you probably memorized this one as root 3 over 2, 1/2, which is, of course, correct, but that square root of 1 is 1, so there you go. Root 2 over 2 doesn't reduce, so we just leave it. Square root 1 over 2 is just 1/2, so we have 1/2 square root 3 over 2. And then square root 0 over 2 is 0, square root 4 over 2 is 1. So there you go. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Everything is a square root over 2. All right, and then everything else you get, you're going to get by reflection. So let's say I want to know what 5 pi over 6 is. What are the coordinates of 5 pi over 6? Well, I know what pi over 6 is. It's root 3 over 2, 1/2. All right, so I'll just say, well, I'm in this quadrant, so the x is going to be negative. So we're going to have negative square root 3 over 2, 1/2. So if somebody asks you, what is the cosine of 5 pi over 6? You know it's negative square root 3 over 2. So what if somebody asks you, what is the secant of 4 pi over 3, right? Secant of 4 pi over 3. So what you do is you think secant is 1 over cosine, and you have to know that. So 1 over cosine of 4 pi over 3. So you have to know that secant is 1 over cosine, cosecant is 1 over sine, and cotangent is 1 over tangent. So I would just go to 4 pi over 3. I would say, let's do a reflection. It reflects from this point pi over 3, and it's a reflection across the origin. So it'll just make both of the coordinates negative. So this one will be negative 1/2 negative square root 3 over 2. And then cosine is the x-coordinate. I need reciprocal because it's secant, so I have negative 2. Boom. That's how you're going to answer questions like that. All right. I'll give you one more little hint about this, something that I use because I don't even, when I showed people this because it's nifty and people like it. That's not how I think though. The way I think about these problems is like this. There basically are only, apart from 0 and 1, or anything that's 0 and 1, I know it. So I can easily get these quadrant angles. The only question is the ones that are off the quadrants. Okay? So let's say I wanted to know sine of 11 pi over 6. I wouldn't do this and then do a reflection. What I would say is there are only 3 numbers in the center of the quadrant. There's 1/2, root 2 over 2, and root 3 over 2. And that is in ascending order of largeness. In fact, I could write it like this. Less than root 2 over 2 is less than root 3 over 2. Okay? So if I wanted to know the cosine, let's say, of 11 pi over 6, I would just look at the x-coordinates here and say, is the x-coordinate larger or smaller? Right? Well, I have the large x-coordinate. Right? It's the large x-coordinate. So that's square root 3 over 2. So the cosine is square root 3 over 2. That's just the large one. All right. So that's how I would know right away that cosine of 11 pi over 6 is square root 3 over 2, because by looking at the picture, the x-coordinate is the big one. And if I wanted to know the sine of 11 pi over 6, all right, I would just say, oh, sine is y-coordinate. The y-coordinate is the smaller number, so that's 1/2. All right, and like the root 2 over 2, you know that those are the ones that are always equal. So if I'm at, any of these cross quarters, then everything's root 2 over 2. And if I'm off the cross quarter, nothing's root 2 over 2. So the cross quarters are always root 2 over 2. All right, so when I'm at one of these points like 5 pi over 3, if I wanted to know sine of 5 pi over 3, I would just go, oh, the sine is the larger number, because the smaller number is going to be the cosine, and it's negative. So right away, I know that sine of 5 pi over 3 is negative root 3 over 2, because root 3 over 2 is the bigger of the 3 numbers, right? And I also know that cosine of 5 pi over 3, well, I can see from the picture cosine is positive for 5 pi over 3, and it's the smaller number, so it's 1/2. Right, if I wanted to know sine of 5 pi over 4, all right, anything that's on, these are called cross quarters, by the way, the 45-degree angles. Anything that's on that 45-degree angle is going to be a square root 2 over 2. It's just a question of whether it's positive or negative. So the sine is the y-coordinate is negative. So that's how I think of how I get these. But you can use, there's lots of different patterns and lots of different ways that people know and understand the unit circle. Next, we're going to talk about how you get the tangents easily without having to get the sine and get the cosine and divide them. That's too much work. I'm going to show you an easier way.